Hello students, we are going to see the second unit, high frequency transmission line. I am Aarti Devarani, Assistant Professor, R.M.K College of Engineering and Technology. So, high frequency transmission line. High frequency means it ranges from megahertz and more. So high frequency signal is otherwise called as radio frequency. In order to transmit the radio frequency, we are going to use the open wire line or coaxial cable. Before going to the topic, we have to see some assumption related to that. When a line is either open wire line or coaxial line is used at the frequency of megahertz or more, certain approximation may be employed leading to simplified analysis of line performance. The assumption are at high frequency, thus there is a chance of skin effect. What is meant by skin effect? While we transmitting the high frequency signal to the conductor, your flow of current at the outer surface of the conductor, not inside the conductor. It leads to internal inductance became zero. Due to the skin effect, the resistance R will increase with the frequency F, but the line inductance omega L is directly with increase directly with the frequency F. That is omega L is very much greater than R. The lines are well enough constructed that G, that is conductance, may be considered as zero. Then we are going to see some parameters related to the open wire line and coaxial line at high frequency. Due to the skin effect, the current is considered as flowing essentially on the surface of the conductor in the skin of very small depth. Hence, the internal conductance and internal flux are reduced nearly to zero. So then we are going to see some formulas related to inductance, capacitance, and DC current resistance, AC current resistance, then resistance due to the high frequency signal. The inductance of open wire line is given by L is equal to 10 to the power of minus 7 mu divided by mu r plus 4 ln of d by a. The d represent the distance between the two open wire lines and a represent the radius of open wire line. Then the formula L is equal to 4 into 10 to the power of 7 ln of d by a henries per meter is equal to 9.21 into 10 to the power of minus 7 log 10 of d by a henries per meter. The a represents the radius of the conductor and d represents the distance between the conductor. Then we see the formulas related to the capacitance. The value of the capacitance of the line is not affected by the skin effect or frequency. Hence, the capacitance of open wire line is with the air dielectric is given by C is equal to pi epsilon r divided by ln of d by a farad per meter, where epsilon r, that is permeability of free space, is equal to 8.85 into 10 to the power of minus 12 f divided by m, that is farad divided by meter. Epsilon r is equal to 1 for air and C is equal to 27.7 divided by ln of d by a microfarad per meter, and C is equal to 12.07 log 10 of d by a microfarad per meter. The effective thickness of the surface of the layer of current is given by del is equal to 1 by root of pi f mu sigma per meters. These are some formulas related to the inductance and conductance. Here the conductance value will not be affected due to the skin effect, but the inductance value will be affected due to the skin effect. Then mu is equal to conductor permeability is equal to 4 pi into 10 to the power of minus 7 Henry per meter for copper, and sigma is equal to conductivity of the conductor, that equal to 5.75 into 10 to the power of 7 mho per meter for copper. The effective thickness is given by del is equal to 0.0664 divided by root of for copper. copper. Then we saw the resistance, DC resistance formulas and AC resistance formula. Then we are going to see the ratio of the resistance to the alternating current to the resistance to the direct current. RDC is equal to 4 into 10 to the 4, sorry, RDC is equal to 4 divided by pi a square. R is equal to rho L by A is equal to K divided by A is equal to K divided by pi a square. While that round conductor with the alternating current is flowing in the skin of the thickness as R AC is equal to K divided by 2 pi A del. Then we are going to see the ratio between RAC and RDC, that is A divided A into root of pi A mu sigma by 2 is equal to A divided by 2 del.